Hello everyone, this is Wei from the vesoft. I'm super excited to have you here in Percona Community Live to share a Nebula Graph, an open source distributed graph database. I am Wei Gu, or in Chinese is Si Wei. I come from China, Shanghai. I am an open source believer and DA of the Nebula Graph. And I used to work on OpenStack before Graph Database. So you can find me in GitHub, Twitter, and this is my website. And my slides will be presented in this URL too. So feel free to reach out to me if you are interested in anything around Graph or Graph Database. Agenda today, I will quickly go through the basic concepts or topics around the Graph and Graph Database. So after that, I will introduce you the Nebula Graph from the basic concept to some more deep dive. And finally, I want to share you some demos. So let's start with why Graph Database. One of the reasons that I think we need a Graph Database is in the workload or the use cases that you care so much of the interconnection between data. For example, we can module, when we're thinking of this module, that you have a person and cooperation, and you want to query the relationship between them, and you have to define them in your database, right? When we are going to persist those information in a relational database or a tabular one, we have to create a bunch of joins that of the intermediate tables between the table that represent those starting point and destination point, right? That's doable, but that's actually quite anti-pattern of the graph pattern. Instead, in a graph database, you can directly mind dump what you are thinking of the relationships module into the schema of a graph database. So that's quite different, and that will make your life much easier when you're dealing a bunch of different relationships here. So another point is the query language. So graph database is only without those burdens. It's designed for the beginning to deal with the relationships of the data, but its query language was designed so too. So if you want to query 3 jumps of data, for example here, player served team, and then from the team to reverse it to all the served players, so this is the 2-hop jump. The equivalent query in Circle in a tabular database will be something like this. You will have nested, you have join things. So this is only 2-step jumps. So imagine your workload refers to multi-hoops of that. I will show you some queries like that. It will be a join curse for you, but still you can make it work, right? So then we come to the third reason, which is the deal maker for many cases, is the performance. So we have found that in a typical graph queries, when it comes to high throughput concurrency queries in a slightly large scale of data, the return time could be easily differentiated from the graph database towards a non-graph database. So the difference could be either it's an online system or an offline system. So that's a deal maker for many use cases like fraud detection. You want to stop this fraud transaction immediately instead of figure out after a couple of hours later. So that is why we need a graph database. So this is the point that I shared with you already. It's a query language. But underlying why the performance differs. So I'm old enough to play with the Snow Brothers. So if you are not familiar with this game, so you are the Snow Brothers. You want to jump from different stairs, and you want to shoot snowballs to the monsters, and then you walk there to kill it. So this is this is in some level similar to when we are doing the relationship of queries in the tabular database. That you have to scan a lot of data, just like you're walking here, until you know its next jump in a join. But instead, when we are doing so, for example, we can create different indexes, but the index comes with cost, right? Like you have this blue bottle, so you can run faster, but still you need to run between the stairs, right? But instead, in graph database, you will have this green bottle of magic. So when you get this bottle, you can fly directly to your next jump, directly in O1 effort. So that makes graph database quite differently. So I know this is an improper metaphor, but I want to make sense of the difference of different scenarios here. So later you will have more ideas on how it differentiate underlying in the system design side. So then let's move on. What is a graph database after all? So I'm quoting the definition from the Wikipedia here. So basically, graph database is a database that will persistent graph in a graph structure, and also semantically query the data in a graph pattern. And when we are saying graph, we are actually talking about the nodes, the edges, and properties. We already know that in math, graph refers to the vertex and the edges. But what is the properties? It's actually just key and value attached to them. And I will dive into that later. So I assume that we all know what is graph and what's a graph database, but there are some graph databases out there already. Why do we need another one? Why do we need Nebula Graph? And here is why. One of the reasons is that Nebula Graph is designed from day zero to handling the large data volume of data. And I want to quote this tweet every time I want to share something about Nebula Graph, that we all have the memory that like 1 year before, we have this ship, I forgot the name, it's called green something, stuck here in this river. And it takes us, it takes the world like a couple of months to make it work, to make it go through the river. It's very hard, and the world is waiting for the ship. But this is another one. So it looks quite similar, right? It's a smaller ship with a couple of guys, and this one man just pushed the ship, and the problem was solved. So the problem here is that we all know that the problem that we are trying to solve can be quite different when it comes to different scale. And Nebula exists because it's designed to handle hundreds of billions of vertices and trillions of edges while providing millisecond level latency. So that's why Nebula Graph was designed. And here are some data provided by our community user from Tencent and Meituan that in their comparison and benchmark, that Nebula excels in the high volume data in high throughput rate and write. So when a data volume comes into a huge level, in Nebula it stands out. And here is why. So then hopefully I want to give you some brief introduction of how it was designed, and you will have more idea on why it excels in the large scale volume of data. So this is the brief architecture of Nebula Graph, and actually underlying we have only 3 types of processes in Nebula Graph core. So one is the query node, the other is the storage node, and the third one is the meta node. and the name is quite plain and straightforward. So we actually have the computation layer and the storage layer separately. And in that case, you can scale different roles of the workload based on your traffic patterns easily. And another thing that we design Nebula is share nothing architecture. That means our query engine are stateless, so you will have the ease of the scaling. You don't have to put all the query engine in same spec, and you can specific different types of query engines for different workloads in one cluster. And it also comes with more ease of the fault tolerance, of course. And another thing is auto sharded. So we all know the modern distributed databases have this design pattern as well. And actually, we we shard data based on the hash of the key. And we implement our own implementation of the raft, both in the storage side and the metadata side. So, and that's the bird view of Nebula Graph. So let's dive into a little bit. So before we are diving into the storage and the query engine, I want to give you some brief introduction of our data module. So remember, we are talking about the graph database. It's modeling the data in a property graph. So what is property graph? As I mentioned, it's actually just the key and the value attached to the vertex or node and the relationship or edge. So for example here, in this graph, we have cooperation type of node or vertex, and inside the vertex, we want to put more information. And it's proven that the property graph module is quite straightforward and useful. So we define a schema of this type of node with the name and location. So you can have cooperation name and cooperation location in the Nebula Graph. And similarly, you will have the properties in the relationship or edges here. So here we have the person work as a role in cooperation. So the role name here could be CDO, the Chief Database Officer. And you can have another property called start year. So you work at the CDO since 2019. So this is the properties in the edge. So here we have the schema, right? So in Nebula Graph, we called the type or a set of properties of a given type of vertex tag. Quite straightforward. And similarly, we call the equivalent concept for edges or relationship called edge tab. So edge tab define a set of properties like this for edge, and it's distinguished one type of edge. And yes, we have the type of vertex as tag and type of edge as edge type. And how about the vertex and edge? Yes, for vertex, how we distinguish one identity of a vertex, we just use a vertex ID. And how we attach the properties, we just we create different tags, and different tags has different set of properties, right? And we can attach either 0 or more tags to given properties. For example, we can have someone called Tom Cruise, so we can attach a single tag for Tom Cruise, and also we can attach an actor tag to Tom Cruise, and you can do it in the same time. And so how about the edge? So in Nebula, this is quite unique that we define our edge in a full tuple. So this is different to a lot of most of other graph database. So in this full tuple, it's quite straightforward that you have the source vertex ID and destination vertex ID, and you have the type of the edge. For example, it's as row or hold share or is branch off, right? And also we have the fourth field for identify one edge. It is called rank. It's quite strange for the fresh users, but I want to give you more insight on this. So rank is just a number that you want to distinguish of one edge between two nodes or two vertex. For example, think of you want to use the edge to represent a purchase activity. So when people can purchase from one shop in multiple times, so in that time you can put your purchase order ID at the rank. So it will, in that way you don't have to use two legs and add an actual node in the middle to represent this one transaction. So this is quite unique to Nebula Graph. And other fun facts are that the edge type is actually not related to the type of vertex or the tag of vertex. If you notice here, only the vertex ID are existing in the tuple of the edge. So that's one point to be highlighted. And then we will have more idea on how the data is persistent in the underlying storage node, and we will dive into that now. So this is a diagram that's showing you how we persist the vertex and the edge in the underlying storage node. So as you can see, it's actually quite looks like a KV storage, right? And underlying, we actually are leveraging the RocksDB as our local storage engine. So here the yellow one is here refers to one vertex, and the red one refers to another. So the green line refers to direction, the edge, starting from the yellow one to the red one. Yeah, and underlying, we are persisting this vertex as one with given tag. So if you have multiple tags, that's multiple lines of KV here. So if you notice that we actually have a duplicate lines of one instance of edge here, and this square refers to different shard or different partition. And actually, we are sharding or partitioning the data based on the hash of the vertex. So you can see that we hash the vertex ID, and we will have the result refers to different partition. And here it is the yellow one is hashed into partition X, and the red one is hashed into partition Y. And how about other fields? This is the partition ID, right? Why do we need a partition ID? Because we don't treat one storage instance as single partition. We actually divide, we introduce way more partitions or shards comparing to the storage number. For example, if you have 3 nodes as a storage node, you can have 100 partitions or shards, and they can, so one node will have like more than 30 partitions. And with that design, you can have data being balanced in a better with our observation. How about the nature of the graph data? We know that, as I mentioned, that when you're doing the graph traversal in the graph database, that is basically O1 cost when you're doing the, want to get all the edges from one single vertex. And basically, graph database are persisting those data in the adjacency list. But how do we persist the adjacent list in a KV storage? And here is why. You can see the fields of the key is the type of data, the partition ID, which is determined by its VID, And then we come to the type of the data. Either it's the type of the vertex or the type of the edge. So from this design, we already know that everything, the key is persistent in the LSM tree, RocksDB. So it's already sorted. So that means given vertex and all its relationships are sitting closely together with the locality feature, and that's actually slightly equivalent to adjacency list. And yes, but why we choose to use KV to storage, so it's so structured storage to persistent the graph data. So the reason is the KV storage is quite mature, and it's really easy to implement a distributed system with Raft on top of that. And also there are so many best practices, papers, and engineering optimizations out there, so we can leveraging them. And yes, so as I mentioned, that vertex are sharded by the hash vertex, and the edges are located with the vertex, so that's why it's a adjacency list. But why it's duplicated? So actually, in a distributed graph database, you cannot put everything in one node. That's a most ideal situation. But unfortunately, in the data volume in today, you have to distribute them. So either you cut your edge or cut vertex. So in Nebula, we cut the edge. So that means you have two replica of the data, duplication of the data in both sides of the vertex, both sides of the vertex. So the gain from this design is that either you want to traversing from this point or traversing from here. You can have this. You can have the destination information just in O1 is co-located. So yeah, and that's basically the design of the storage node. And you can be noticed that the serialized value is actually the value of this KV, and we store the value in a binary pattern here. And one thing to mention is that as I mentioned, that there are a bunch of optimization on RocksDB or KV. For example, we can leverage the whiskey design, the KV separation, and we have already bring that in 3.0, and it bring a certain performance improvement. That means if you turn the KV separation here, so in certain cases, some of the value can be separated, can be persistent separately in another places. So that will be helpful when you have a bunch of properties. And that's only one case of the KV theories that we can leverage to improve the storage. With all of this design, when we are doing a graph query, so when you query the given vertex underlying in KV, it's just the prefix 6. And when you want to, for example, get neighbors, get all the next jump of one nodes, that will be underlying in KV. It will be the prefix again of the edges in KV. So I hope you have more idea on how it's designed in underlying in the storage level. So then we come to the computation, the query level. So we also call the query node a graph node. And frankly, the query engine is designed quite similar to all the other or traditional databases. Mainly, we have four parts of the query engine, which is the parser, the validator, the planner, and the executor. And literally, the parser is handling firstly handling our one of the query, and the query will be translated into AST, and they will be passed into your initial execution plan by the validator. So it will translate it into plan and validate your query if it's allowed or not. And after it's validated, it will be passed into the planner. So planner will transform your original naive plan into a more optimized one. For example, here, you will start with the get neighbors to traverse all the data. And then you want to filter like where specific property is smaller than another value. So actually we can already make it more optimal by push down the filter to the get neighbor query. So the get neighbor query is actually an operator that will be executed from the graph node and calling the remote storage node. So if you put the filter in this single query, you can fetch less data and it will be much more performant. So this is only one of the optimization role. So that's what Planner is doing here. And finally, with the optimized, there are a bunch of rules, and after everything is applied, you will have optimal execution plan, and the executor will initiate the meta client and the storage client. It will call your distributed storage engine and to get the data needed and make the further handling in other operators. So think of you are doing this query. You want to go from 1 to 3 steps from this single point over all type of edge types bidirectionally. And this query will go into parser, will be passed in the AST. Then it will be validated and translated into a plan execution plan, and then it will be optimized in the final plan, and then it will be executed by executor. So executor will call the meta and the storage part of the system when it's needed, and then return the result to the end user. So this is the a query lifecycle in the query engine. So now we have some ideas of how Nebula Graph is designed. Then I want to share you more information on our query language. So actually Nebula have evolved for a couple of years, and we evolved from the original design to a quite different version now. So we define our native graph query language called ngQL first place. So basically this is all the queries that you can do in a graph. And this is first one is a Go that I already show you a lot of times. So you can traversing from given point in different patterns with Go. And another pattern is lookup. So lookup is a different query that you don't know exact ID of your starting point of your graph query, but you know some of its conditions or filtering conditions, like you can describe. So find all those with the property name called Tony Parker. So lookup will do that for you, and underlying is leveraging an index of given properties. And also you can actually directly retrieve the properties with the fetch prop. So you can fetch all the properties from given vertex ID or edge, the full tuples of edge. And another two are a little bit more complex, but it's actually quite native, a native graph query that you can actually find paths. So you can either find shortest or all paths or no loop paths if you specify different parameters here. So it's basically find a BFS from 2 points. So one is here, 1 point is player 102, another is the team 204. So it will find the shortest path between the two data over all of the edges and return the path. So another one is the subgraph. Subgraph is doing the everything that's traversing from one single point until you reach out your end condition. And here we want to limit it to 5 steps. And yes, it's literally means you will get the subgraph of the whole data starting from 1 point here. And finally, the interesting part of the NGQL is we bring the pipeline as we have in the Unix shell, that you can put different queries connected with the pipeline. For example, here you want to traversing from this point over this pattern, and put the destination ID here in this query as the output of this query, and then you can go from this last step of the traversal and moving on, and you can compare, you can put the lookup and the fetch and lookup together to have a more complex queries. And that's the most of the NGQL part. And since version 2.0, Nebula Graph bring the support of another popular query language called OpenCipher. So it's initially brought by the great Neo4j, and with the Cipher support in the DQL, we can have more patterns, more complex patterns like this. So in this pattern, you want to match something starting from a property name with name Tim Duncan and this outgoing relationship to v2 and a reverse lag to v3, and you want to return the v3s. Similarly, you want to find a query that's matching all the vertex with tag player, but the condition is all those v player content v not connected with other vertex, or we call it often node. So similarly, you want to query this pattern with the ID of v2 in list of this, and you want to, in this pattern, you want to query, return the v here. The reason that we choose to design our own pattern of query is that the original team of Nebula Graph come from specific domain or industry that's mainly on the fintech. That in their scenario, previously they designed another graph engine to handle their specific industries problems. NGQL is quite enough for describing their patterns, and before we introduce Cipher, there are already a bunch of teams leverage Nebula NGQL handling their quite large data volume. For example, the WeChat team leverage the Nebula Graph just with NGQL. So it's the most performant query. And when more of the users joining the community, we figure out that many of them are familiar with the Cipher. So we decided to support Cipher as well. And some of you may already know that there is actually a standard organization there that we will have a ISO GQL standard, and we already even have one draft there, but no vendor is already actually supporting that, and Nebula Graph is working on that. So in next major release of Nebula Graph, we will be fully compatible with the future ISO GQL, the graph query language as well. So that's all of the query language part. And then we come to why yet another graph database. So I think from my point of view, it's open source. Nebula Graph is open source and Apache 2.0. And with the help of the community joint effort, we now are quite mature that we have our first production user in 2019. We open sourced in 2018, and in 2020 we have our 1.0 GA, and in the beginning of this year we have 3.0 GA. We brought a lot of new optimizations to the ciphers and the push down, and we bring a lot of more tooling chains in the ecosystem. And so as our community users, and until now we have more than 300 users in record in different teams, and some of them are startups and some of them are tech giants like WeChat, like Meituan, Akulaku, Huawei, etc. And if you are interested in more use cases, just visit our website here. There are a bunch of sharings, articles, and the best practices on their adopting and migrating to Nebula Graph. And so the last reason that I want to emphasize about why Nebula is Nebula Graph comes with a rich ecosystem. So if you're looking at the red part, so this is our core part of the graph database. So we have a bunch of different open source projects surrounding the deployment, the optimization, the cloud native, and regarding the graph algorithm, graph analytics, we have a bunch of projects. And regarding of the data visualization and other graphic projects, we have some of them out of box, and most of them are open source as well. And we have different clients out there. Some of them are mainly maintained by our team, and some of them contribute and donation and actively maintained by the community. And our ETL toolings, our data utilities supports a bunch of different data sources. And you can we also have backup and restore utility and integration with the Elasticsearch. So I want to give some of them in a more close look. So one of them is Nebula Graph Studio. It's an open source GUI console of Nebula Graph. For example, in real world, you want to in 3 depths of the host share relationships of given node here. And you can do that in a command line, right? But if you are doing that in the console of the studio, and you can choose to render it in a visualized way. And the studio can also support to, you want to import data in the import here. You can select the definition of data in a visualized way. And you can define the schema here visually. So next one is called Nebula Graph Explorer. This one is enterprise only. It's not open source offering, but one of the sweet feature I want to here show you is that we are doing it quite good in the visualization on other level. For example, this is a feature called Visual Query Builder. That you have noticed that in the real world, your graph pattern query can be quite complex, and to writing a complex graph query can be we can make it push it further with the query builder. So for example, here I drag the nodes here, and I drag the connections between the nodes, and you select the filtering conditions here, and then you can generate a query with this. So it's quite sweet feature. I really love it. And regarding the visualization in the Explorer, is more powerful here. So you can do a lot of more things. And one of the things that I want to share is 3D rendering. Nebula Graph is one of the first team that offering 3D mode in the graph data visualization. So it's quite cool, right? And next one is the Nebula Graph dashboard. So it's another graphic tool, but stressing the ops domain. So in Nebula Graph dashboard, you can out of box have all the optimization, the lifecycle management, and the alarming and some provisioning works in one single tool out of box. So we have an enterprise offering and another open source version too. So on the SRE and the cloud native domain, we actually have open source Kubernetes operator. We have our Docker Compose and Ansible offering. We have our projects on Grafana, Prometheus, Stats Exporter, and Backup and Restore. So it's agent based. You can run it as your sidecar. So one thing to mention is Nebula Graph is cloud native, and we are enriching cloud native landscape in the database category. So you can see in the category here. So this is the Nebula Graph. Yep. And also, our team is maintaining a managed service on different cloud providers, and the AWS version will be offered in upcoming weeks. And for now, you can already search Graph Database in the Azure marketplace, and you will find Nebula Graph Cloud there. So feel free to try it. And regarding the data import domain, we have a bunch of different toolings helping you ingest data from other sources to Nebula Graph. So we have an importer, which is a Go binary file that consuming the CSV files. We have the console that consuming your query strings. And also we have a tool called Exchange. So Exchange is a tooling running on top of Spark that you can exchange different kind of data sources from the different type of databases, from the message queue, Kafka and the Poser, and from the other sources like ClickHouse and etc. Besides the Exchange supporting different data sources, Exchange can writing to Nebula Graph in two kind of way. One of way is a server based, so it just make the writing DML queries towards Nebula Graph. So the other way is to ingesting the underlying SST file. So when you're using this type of capability, you actually sideload the data. You offload the underlying sorting compute power of the Nebula Graph cluster. Instead, you are generating the underlying SST file from your Spark cluster. So, for example, as we know, WeChat is using this capability to do their T+1 huge data volume ingestion. We also have a bunch of different clients and connectors, like we have Spark connector, Flink connector, and different languages, etc. And now we have two languages of ORM of Java and Go. And recently, we just have the Spring integration open sourced by one of our community user. So then we come to the graph analytics and algorithm. So we have two projects surrounding this domain. One is called Nebula Algorithm. So we have a bunch of de facto graph algorithms supported out of box here, and it's also open sourced. It's based on the Spark infra. So the good point of this that you can leverage your existing stack capability and stack competence to play with Nebula, so you can run different graph algorithms that consuming the graph data sitting in Nebula Graph. So if you care more about the resource utilization ratio, so you can choose to leverage Nebula Analytics. So it's based on another open source project, but it's an enterprise only offering. So underlying is written in C++. And feel free to check out in our documentation on the Nebula Analytics as well. So finally, I want to share you something, some playable demos. So before that, I want to introduce graph use cases, so make more sense of how it should be looks like. So I want to quote one of our users, which is Meituan. It's a Chinese giant app equivalent to the Yelp. So they are leveraging graph database, Nebula Graph, for like more than 50 different scenarios in their systems. So one of them is they are using AI agent, but underlying the data will be queried in Nebula Graph. So for example, if you are asking the agent that is there any McDonald's nearby the street full bar. So underlying Meituan will query the data in the knowledge graph. And another one is more interesting, is related to the explanation of a recommendation system. So how do they leverage this? So the end user will see this. They will when you are searching your favorite restaurant nearby, so there will be one line of explanation of this recommendation. For example, those whom from Beijing enjoying Korean cuisines said this restaurant is great. So this is one of the reasons that why we recommend this restaurant for you. So how could this be done with the graph? So it's quite straightforward. Actually, they put all the different profile keywords of different users and different dishes and different restaurant, and they put them together in this knowledge graph. And when they have a user and a recommended item, they just use a find path in this knowledge graph, and they find one of the paths that's ranking the high, and make this path into this line. So it's quite interesting use case of the graph on the recommendation system. So graph database it excels in many and proven in many use cases. For example, the social network, you can, for example, in LinkedIn, you will have some n degree common users you may know. So this underlying is powered by graph. So fintech or other domains, risk control. So when transaction coming, so you can detect if it's done by a fraud graph pattern online. So public security have similar use cases, and the knowledge graph can be stored in a graph database. So in that case, your query pattern involving complexity, multi hoops, it will be much easier in this way. So there are some graph related machine learning works. So you can integrate machine learning, the GNN, towards the graph database, and some of our users are doing that. And so many other scenarios, they're carrying so much on the connections between the data. So if you are doing that massively in large scale, so it will be a perfect fit to on a graph database. So, but then I want to demo you something here, and we don't have much time. So the first one is my side project. It's a toy project called Nebula Corp Real Search. So everything is open source here. You can fetch it here. You can run it on your local environment. So let's start with the graph modeling. That's why we are doing graph database projects in the first place. How you want to persist everything in a graph. So it's very familiar that I already showed you this graph, right? So in this small project, we have two type of nodes or vertex. They are person. Person will come with the property of name and age. So person can be relative with another person. Person can working as role of other corporation, and person and the corporation have the hold share relationships, and the corporation can be a branch of another one, right? So with this graph schema defined, we can query from one corporation to know all the related shadowed persons or corporations related to this single corporation. So it's a quite normal use case in this domain, right? And in Nebula Graph, you can do this. With this query, you can find this node is our starting point. Then we will know underlying there are so many other relationships with this single company. So isn't that quite cool? And then how it's built, and everything is actually on the GitHub. So in short, it's just the system will come with the front end. It will help us render the graph, and the back end is just a web server that's handling your query. For example, you want to query one point. This point will be sent to the server, and in the backend server, it will compose a graph query for you and call the graph to the graph database. And everything is just connected in this way. It's quite straightforward. I'm not going to dive into more details, but you can see here in the backend code, this is actually underlying a match query that it want to query from this point to with all type of edges from 1 up to 3 jumps of the relationship. And afterwards, I want to demo you. And it will finally look like this. The UI of the system is just this. Is quite naive that you can fill the entity here and give an enter to make this analysis query. So it looked like this. You give the name like C132 and enter, and everything will be rendered here, and you can actually see it's calling the backend, and I'm not cheating. And from the result, you can have more insight in the interface, that you can know a bunch of other cooperation is related, and behind this cooperation there are a bunch of other people related. So isn't that interesting? And then we come to a final demo. So this is actually another open source project called Amundsen. This project it was initialized by Lyft and donated to the Linux Foundation. So you can find it here in the GitHub. So it's an open source project that doing data discovery or metadata lineage management. So you can have more information on its website. But how it's related to graph database, and actually Amundsen is underlying powered by graph database as its storage layer. So it persistent. What Amundsen is doing is to handle all the metadata in your data lab. For example, you have your Hive, Postgres, Redshift, you have many data warehouse and databases, and you have your pipelines. You want to manage those metadata, so you don't have to make people fan out information in your Slack group or Slack channel. So Amundsen make it possible to make all of the metadata stored in graph database as the source of truth. And you can query them either from API or in the fancy front-end service that I will demo you later. So and this demo is based on Amundsen running on top of Nebula Graph. So this is the you want to search the table metadata with test, and you have a bunch of different schema or tables. So you click one of them, you will have everything around the metadata of this table: owners, frequent users, tags, and descriptions. And you also have everything around these columns metadata. You can have more data around the column level. And the more interesting thing is around its data lineage. For example, in this table, you have upstream, one upstream and 2 downstream, and that's the data lineage there. And also you can query the lineage in a visualized way. So this fancy system is quite usable by many teams, so they can have this single view to have everything connected and managed. So it's quite a good use case of the Nebula Graph. And underlying, if you are running Amundsen on Nebula Graph, you can also have the the ability to query the information from the visualization provided by the Nebula Graph already. So that's another benefit that we want to persist some data in a graph database or Nebula, because most of the graph database is offering your graph query plus the graphic console, and the graph console itself can be either for the query language can be a flexible DSL of your metadata system, and this query system itself can be leveraged by your domain expert to get more insight directly from the graph data. For example, one can easily have more insights in the graph database like this. So in this view, you will have everything connected easier, right? Remember when we are doing the Amazon web page, underlying its huge graph query like this, and this is the code, and the query looks like this, and I didn't explain you the pattern of multiple match, and in this single query you actually query the table with the ID of this ID plus a lot of more connection queries, like 10 of them, and each of them are querying to different data types. You can query so much pattern in one go and in really short time. And that's all of the demo. And actually, the support of Nebula Graph in Amazon is still in working in progress. And I'm putting this RFC in the Amazon community in this issue. So if you are interested, just check out this issue. So let's do a recap. So basically, we have know what is graph database and why we need it, and what is Nebula Graph. So Nebula Graph is a linear scalable, performant, and the Nebula Graph comes with a strong open source community with a rich ecosystem with a bunch of different projects offered around Nebula Graph. Thank you for your time. So if you're interested in Nebula Graph, feel free to check out our GitHub repo here. And this is Wei Gu from vesoft. And thank you, everyone. Thanks, Percona. So thank you.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.